Hi there. My name is Rebecca Weaver. I'm going to be doing uniform motion application problems today. In order to do this, we're going to talk about distance, rate, and time. So we need to know exactly what do we mean by each of those. The distance an object covers over a period of time is related to the speed at which the object is traveling. We're going to call our distance lowercase d. Then rate is the speed at which the object is traveling. We're going to call that lowercase r. Time is the amount of time required to travel that given distance. We're going to call time lowercase t. So we need to look at our equations. If our rate is distance divided by time, rate or speed has the units such as miles per hour or centimeters per second. We could rework this equation by multiplying t to both sides and get that distance equals rate times time. Distance has units such as miles or centimeters or meters or kilometers, something like that. If we were to divide both sides by r, we see that we would get time equals distance over r. Time has units such as hours or seconds. And that's helpful in identifying exactly what it is you're looking at. So I'll just leave our equations up there, and you might want to do that as you work these problems. And let's just say that Billy rode his horse 15 miles in an hour and a half. What was Billy's average rate of speed? So I know that I'm going to be looking for rate, so I'm just going to write that rate equation down. And then write that rate is 15 miles divided by 1.5 hours. This is going to be equal to 10 miles per hour. You might also see this written as 10 mph, or miles per hour. We could also have done this problem in miles per minute. So we would have written 15 miles over 90 minutes, because that's what an hour and a half is. And then we would get that the rate is 0.17 miles per minute. So let's look at some more problems. Let's say that Jacob runs with a speed of 7 miles per hour and Jesse runs at 5 miles per hour. They begin at the same spot and they started running in opposite directions. Now, after some time, they're 33 miles apart. How long have they been running? All right, there's Jacob. Here's Jesse. All right, they've been running and they're now 33 miles apart. Now, the key to this problem is that they've been running for exactly the same time because they started at the same time. Note that their combined distance is 33 miles. Now, neither one of them ran 33 miles. It's just the combined distance is 33 miles. So we're going to set up equations for both Jacob and Jesse. So let's look at Jacob. Distance equals rate times time. So his rate is 7. I know that. Jesse, her rate is 5. So I have D equals 5t for Jesse and D equals 7t for Jacob. I know that their combined distance, now notice that each of these is distances, their combined distance is 33. So I can just write that 7t plus 5t is 33. I'll then get 12t equals 33. And then I want to divide both sides by 12, and I'll get the time as 2.75 hours. And that's what they were asking for. How long have they been running? And I found T. Let's look at another problem. Let's look at Reba. Now, she's driving a total of 925 miles in 2 days. Not too bad. If she drives for 6 hours the first day at an average of 6 miles per hour faster than on the second day, and then she drives for 5 hours on that second day, what's her average speed over each day? Now, the key to this problem is just take it one day at a time. The combined 2-day distance is 925 miles. Her speed the second day was slower than on the first day. That's what that's supposed to say. All right, got that fixed. Her speed on the second day was slower than on the first day. If we call the first day's speed x, then the second day we would need to call it x minus 6, because whatever it is the first day, it just take away 6, and then I'll have that second day. So let's write some things down. I know that distance equals rate times time. Now for day 1, that distance was x, which is my rate, times 6, which is my time. Day 2, that distance was x minus 6, which is my rate, times 5, because she only drove for 5 hours on that second day. So now I could add those two distances and say that that equals 925. Perfect. Now I can just solve this thing. I can say I'm going to distribute that 5. Notice I distribute it to the x and the minus 6. So I have 6x plus 5x minus 30 equals 925. Simplifying that, I have 11x minus 30 equals 925. Then what I'm going to need to do is add 30 to both sides. So we're adding 30 to both sides. What we're going to get is 11x equals 955. So I'll get that x, which is her first day's speed, is 86.8 miles per hour. Slow down, Reba. My goodness. So day 1 speed was 86.8 miles per hour. It's a wonder she didn't get a ticket. Day 2, just subtract that 6. Oops, that's supposed to be an 80. Hold on. Okay, that looks a little better. I can subtract 6 from that now. All right, so if you need any help with any of these, be sure and email me. And have a wonderful day. Bye now.